Well, this ShowMe is about solving quadratic equations using a method we've spent a lot of time on already, factoring. The crucial cultural element of this particular lesson is to understand that when someone tells you that you must solve something, you have to discover every solution that you can and give as complete a list of solutions as you can. So, in your math classes, when the instruction is to solve, it's not your job to come up with one way of making the equation work. It's your job to come up with every way to make the equation work. And quadratic equations always have two solutions. You'll learn in later classes that sometimes those solutions have a different nature. But quadratic equations always have two solutions. Sometimes it's the same solution twice, as we'll see. But it's important to understand you're responsible for listing every possible solution when you answer these problems. Fundamentally, all of these problems reduce to a situation where we have a product that is equal to 0. Well, we know an awful lot about multiplying by 0. We know that if you multiply and you get 0, every number involved could be 0. So when we say that AB, a product of two numbers, is 0, every factor could be 0. We don't know if that's the case, and frankly, it only takes one. If we had ABCD equals 0, that's true, even if A is the only one that's 0. But because you're responsible for listing every way that makes the problem work, if it says AB equals 0, you need to account for situations where the first factor is 0. You must also account for situations where the second factor is 0. The only time you wouldn't have to worry about that is if you had something like 2 in front of AB. 2 is a factor, but we know that 2 is never going to be 0, so you wouldn't have to make an equation for that factor. This is going to be a really important part of our strategy, as you'll see. Well, let's start with the training wheels on. This particular equation features a left side, an expression on the left side that has already been factored for us. This is to emphasize the concept we just explained. On the left side here we have a product. We have x plus 5 being multiplied by 2x minus 6, and that product happens to be 0. Well, when we were talking about AB, it wasn't so hard to see that if AB equals 0, then either A or B has to be 0. The same thing is true here. It is either true that x plus 5 is 0, or it is true that 2x minus 6 equals 0. We don't know which one, so we have to account for both possibilities. So we solve these equations separately. On the left side, subtract 5 from each side. X could be negative 5. On the right side, subtract 6 from both sides. Add 6 to both sides, and then divide both sides by 2, and x could be 3. If you go back and put either of these numbers into the original equation, you'll find that it's true. Negative 5 will make the first factor 0, and 0 times anything is 0. In the same way, 3 would make the second factor 0, and x plus 5, no matter what it is, times 0 is going to be 0. This is the way we'll finish every one of our problems. If we were to analogize this to a process, this is how the last part of the process is always going to look. How we get to this position might seem different from time to time, but once we get to a situation where an expression on one side is completely factored, the rest of the problem will always proceed in this fashion. Let's do one more of these just to make sure that it takes. Here, the left side again has already been factored for us. So we know that one of these things has to be 0. We just don't know which one. Either 3y minus 5 has to be 0, or y minus 2 equals 0. Now we solve the equations separately. On the left side, add 5 to both sides. and then divide by 3. So y could be 5/3. On the right side, add 2. Y could be 2. We don't know which. We know one of them has to be true, or our equation won't be true. So this is a way to write the solution. Now, you realize there's more than one solution. There's 5/3 and there's 2. Actually, that's the way to write the answer. We've talked about that distinction before. Another way to write the answer, and a very acceptable way indeed, is to write it as a solution set. A set containing all the numbers that meet the conditions we set. The conditions were set by the equation. We want the numbers that make that true. Here they are. So either of the ways that are circled there at the bottom are acceptable ways to present your answer. They're acceptable ways to list your solutions. Okay, let's play a whole game here and see how it looks. We're starting with an equation that has not yet been factored, so we're going to have to factor it. Well, we're interested in figuring out what numbers that have a product of -48 have a sum of -8. Recall that we do that because the number in front of x squared, which we refer to as a, multiplied by c, which we would say is -48. 1 times -48 is -48. To make this work, we need to discover numbers that have a product of -48 and a sum of -8. Well, the factors of -48 include -12 and 4 as a pair. And I think that the -12 and 4 have a sum of -8, so we'd like to use those. The next step is to split -8x into 2 addends using those numbers. So now it becomes 1x squared minus 12x plus 4x minus 48. And of course that still equals 0. We haven't changed anything. The -8x is now written as -12x plus 4x. Now factor by grouping. The first 2 terms have a common factor of x. When we factor that out of the first 2 terms, x minus 12 remains. The third and fourth terms have 4 in common. We factor that out, we get x minus 12 again. Well, now we have 2 terms, each of which has x minus 12 as a factor. So factoring that out, we're left with x plus 4. And now we have factored the left side of the equation, just as we learned to do in previous ShowMes. Now, what will make this 0? Well, either x minus 12 has to be 0, or x plus 4 has to be 0. Well, on the left side, if I add 12 to both sides, x could be 12. And on the right side, if I subtract 4 from both sides, x could be -4. That is one way to present the answer. Another way, of course, is the solution set. If I would write a little more neatly, it would make a little more sense, I'm sure. -4 and 12 are elements of the solution set. That's another great way to write the answer. The process is not different. In fact, what we're doing is we're building on skills we've already established. After knowing how to factor, it's time to figure out what to do with that factoring skill. And one of the coolest things we can do with it is solve quadratic equations. Well, this is a quadratic equation too. However, it's not in what we call standard form. Standard form is ax squared plus bx plus c equals 0. Whenever you want to solve a quadratic equation, the first correct step, usually, is to put it into standard form. The reason we do this is so that we can exploit the zero product property we talked about earlier. We want to factor the left side so that we can use the idea that if all those numbers on the left side multiply to 0, then each one of them could be 0. We can't exploit that, of course, if 0 is not on one side of the equation by itself. Again, this is called standard form, and the first step you should follow every time you solve quadratic equations is to put them in this form. Now that, I guess if you're going to solve using square roots, maybe not so much. But if you're going to solve using factoring, and some of the other techniques we're going to use, then standard form is the rule. Well, standard form is the rule here. Let's get the negative 36 out of there. We do that by adding 36 to both sides. The left side becomes x squared minus 12x plus 36 equals 0. Now at this moment you could recognize this left side. We've seen it before. We've seen that pattern many times before. It's actually a perfect square. If you didn't recognize it, that's okay. Quickly take a times c. 1 times 36 is 36. What factors of 36 have a sum of negative 12? The pairing we're looking for is negative 6 and negative 6. So we have x squared minus 6x minus 6x again plus 36 equals 0. The first two terms factor because they have x in common. We have x times x minus 6. Whenever this central sign right here is negative, this one will be 2. The third and fourth terms have 6 in common. Negative 6x divided by negative 6 is just x. And 36 divided by negative 6 is negative 6. Now we have two terms that each have negative 6. X minus 6 is a factor. So we have x minus 6 times x minus 6 again. And if you didn't recognize it as a square before, you certainly should now. If you don't, that's okay. You can always get there this way. If you do recognize it, you would have saved yourself a little bit of work. Now, squares have repeated factors. That's why we call them squares. So in this case, either x minus 6 is 0 or x minus 6 is 0. Now, that means that x would be 6. And your solution set would be a lonely one, but still an acceptable way to present your answer. I've seen that process a couple of times. This is how it works. Try one more involving a little more complicated factoring and then wrap this up. So here's our final example. Again, it's not in standard form yet. Standard form always has 0 on one side by itself. That 3 needs to be out of there. So we'll subtract 3 from both sides. We'll have 3c squared plus 8c minus 3 equals 0. Well, following our factoring procedure, we need to take 3 times negative 3 and get negative 9. We need to know factors of negative 9 that also have a sum of positive 8. I think that negative 1 and 9 fit the bill nicely. So we turn this into 3c squared minus 1c plus 9c minus 3 equals 0. The first two terms have c in common, leaving us with 3c minus 1. The third and fourth terms have 3 in common, leaving us with 3c minus 1 again. Well, now we have two terms that have 3c minus 1 as a factor. Factor out 3c minus 1, we're left with c plus 3. Now we've factored the left side. Now we know that it's true that either 3c minus 1 must be 0, or c plus 3 must be 0. We don't know which, so we solve them both separately. For 3c minus 1 equals 0, add 1 to both sides, and divide both sides by 3. c could be 1/3. Of course, subtracting both sides from 3 on the right side, subtracting 3 from both sides on the right side, we have c equals negative 3. So c could also be that. Here's one way of posing your answer. Of course, it's also acceptable to pose your answer as a solution set. I hope this has taken some of the sting out of these problems. Solving quadratic equations is a hugely important pinnacle goal for the first algebra class traditionally taught in the U.S. education system, class usually called Algebra 1. You've got to master this skill. It's very, very important. Later you'll be solving equations of even higher degree, and they usually end up at some point with quadratics as we break them down further and further into expressions like this one. Of course, when they have a higher degree, they have more factors, but the process is still largely similar to this. That's why you must master this first. You're going to need a lot of practice of this, and I'm sure your teachers are going to give it to you. I know my students are going to get plenty of practice.